All right, how's it going? So we're running late today. We ran late in the earlier section too because we're trying to get stuff turned in and such. So there's a sign-in sheet going around. So I downloaded PA2 this morning at 8 o'clock. If I managed to download it, you did not get an email from me. All right, this is important. If you got an email from me saying I could not download PA2, you have to talk to me like right now, like right after class or something. So there's a few things that have gone wrong. Either people have not turned in their code, which is an easy explanation, or they submitted it to GitHub instead of GitLab maybe, or they did not call it PA2, or they did not set me up as a reporter, or there's cases where it looks like you're naming the repository PA2, but it's actually got some different name to it because maybe you did something while you were on the GitLab website, or you tried to make a new version of it, or something like that. So if something weird is going on, right, you got to talk to me like not right this second, but like as soon as class ends, if you haven't already resolved that. I also got a few submissions where there was no source code, just an executable. I need the source code to grade, right? So make sure you turned in the .c file and any other files needed for that. So all told, about a quarter of the submissions were missing this morning at 8 o'clock, which is a little devastating because I cannot grade it if I can't get to the repo, right? That's where I'm going to pull your code from. And I really want to make sure people are able to submit things through GitLab and use GitLab. So I've posted kind of an emergency homework assignment here, which is due Tuesday morning. And this is something you want to do even if it's not an assignment. This will make your life really good 2 weeks from now. So here's homework 2, okay? I want you to go onto your Linux account on linuxengrcs.com. I want you to make a completely brand new directory because you always want to do your projects in their own directories. And people are still working on PA2 and it's in their home directory with PA1 and the ODPs and all that. Make a new directory, okay? Go into that directory and make a file called HL, lowercase, okay? Set the first line to the shebang, #, exclamation mark, /bin/bash, and then add a block of comments right below that. Okay, so #, put in your name, the date, the course number, and a description of what your PA3 is going to do. You can just put in a one-sentence placeholder for now, right? But start your comment block in there. Save that file, do change mode 755 to make it executable, okay? Now do git init, and you only want to do this one time per directory, git init, okay? If things are broken, don't just try git init to see if that fixes it. You only do this once per directory, and the idea is one directory, one repository, one project, okay? So you're in a new directory, say git init, okay? And then do git add HL, git commit HL, okay? Add commit, that's your standard update cycle. And then also only one time per directory per project, git remote add origin, git at gitlab.com, username / uppercase HL dot lowercase git. Okay, so the usual way that we've been doing git so far, do the git remote add origin once, and then say git push origin master, and then log on to GitLab and set me up as a reporter. Okay, before Tuesday, preferably like before class ends if you're on a laptop, right? Just do it now, or after class. Okay, so why are we doing this? Because, and I asked you 2 weeks ago, I suggested you do this for PA2. If you do this for PA3, like today, you don't have to worry about Git anymore, okay? I think for a lot of people, Git is this millstone around their neck, saying, oh, I gotta finish writing this code, and then I gotta do the Git stuff, right? And so the Git stuff gets pushed until, 4 a.m. the morning it's due, and that's when things break, right? If you do this, the Git stuff is done, okay? You've got the repository on GitLab, you've got me set up as a reporter, and I will confirm that I have access to it because I'm gonna download these Tuesday morning, okay? And As a bonus, as you're developing your code, anytime you make changes and you want to save them, git add, git commit, git push. You're done. Your code gets pushed over, it's keeping all your version history. If you accidentally delete your files somewhere along the way, they're at GitLab, right? Git add, git commit, git push. Keeps a copy of the current version over there. You can go back to old versions and so on and so forth. And as one more bonus, you know, if something happens Thursday night 2 weeks from now and you can't push your code over to GitLab, it's already there. The last version that you pushed will be there. And when I download Friday morning at 8 o'clock, I'll get whatever the last version was you pushed. Maybe it wasn't, you know, formatted exactly right or didn't have that last bug fixed, but it's over there, right? So this is like bonus across the board. Okay, question.
So once you do the git push origin master, then after that you just need to git push after that?
No, maybe I would do git push origin master.
Every time?
Yeah.
Okay.
Just throw it in a script.
Okay.
Called like go, and it'll get init, git commit. Yeah. Yes.
If we're working on off our own system, would you require us to also make a copy on the Linux server?
No. Yeah. So this is the straightforward way, right? But if you're working on your own machine and you're not using Linux server, right, do it on that. If you're working on two machines, do what you have to do to keep them in sync and so on and so forth. But at a bare minimum, you can do this on the Linux server, and you've got the Git part totally done, right? And as long as you push stuff over periodically, right, I'll have something to pull down and grade. The real problem is that you spend 2 weeks working on a programming assignment, and I'm up here every day trying to help you work on your programming assignment, and then I download the projects Friday morning, and if it's not pushed over to Git correctly, I have nothing to grade, right? Even though I know you've been working on it and I've seen copies of your code when you've come into my office and so on, there's nothing there for me to like use to give you a grade other than like, well, I know this person's been working hard, so I'll give them, you know, points for that. So I really want to make sure that this part of it is not a problem, right? So this sort of sets you up for that, and it gets you 100 points on an assignment in the ODP homework section. So that's another bonus part. Okay, is that clear? Yeah.
What do you want that directory to be called, the repository?
So the name of the directory really doesn't affect me, right? And so when I say repository, I'm talking about the GitLab repository, and you could call your directory on the Linux server anything you want, right? And really, when you say that git remote add origin, that's where you say what repository to link it to. So you can call it whatever you want.
Okay.
The main thing with putting it in its own directory is that you don't want to have, you know, all the other code that you've developed also in that repository, and that other directory that you did PA2 in already had a git remote add origin, right? It's linked to PA2, and now if you want to link this to PA3, you're going to have to undo stuff and so on. So new directory makes it cleaner. All right, good. All right, so I will grade your PA2s this weekend. I'll give you feedback on things I see, and I will pick the last matchstick. All right, so this is by Tuesday at noon, but like I say, no reason not to do it early. And if there's some weird problem with this, right, it's just one homework assignment. It's not the whole PA3. All right, so let's talk about PA3. So PA3 is a bash programming assignment. It's going to be a shell script named HL lowercase. You want to push to a GitLab repo named HL uppercase. Okay, so uppercase HL is the repo, lowercase HL is the script itself. Don't forget to add me as a reporter. So PA3 is a high-low game. All right, so let me ask in here, how many people have played high-low? Yeah, that's what happened in the last section too. You probably played it, but it's called something different. So this is a number guessing game. one person guesses a number and thinks of a number and the other person tries to guess it, right? So let's play high-low. Okay, who wants to think of a number between 1 and 100?
Got it.
You got it?
Yep.
Okay, don't tell me what it is. Don't tell the computer in particular. Okay, so welcome to high-low. Please think of a number between 1 and 100 and I'll try to guess it. Hit any key when you have a number in mind. Okay, so I'm just going to hit a key. Is your number 50? And you need to tell me if that's a high guess, a low guess, or a correct guess.
A low guess.
So 50 is too low. Okay, so I'm just going to hit an L, and I'm not hitting the enter key, I'm just hitting one button.
Whoa.
Okay, so is your number 75?
Way too high.
Too high, okay. 62?
Way too high.
Too high. 56?
Way too high.
53?
Oh my god, that's exactly it.
Wow. Okay, 5 guesses required. Thank you for playing. All right, so this is what your PA3 is going to do. And the only sort of error checking is if you don't hit H, L, or C, right? If I hit a J, it's going to say, hey, do an H, an L, or a C. Okay, and yeah, so I was thinking of 50. Guess my number. Okay, so so the other thing you can do with PA3 is you can say HL, and you can put in a number. And now instead of playing between 1 and 100, it'll play between 1 and whatever number I put here, such as 1 in a million.
I have a number in mind.
So somebody else want to pick a number, or are you just going to go for it? Okay, you got a number in mind between 1 and a million?
Yep.
Okay. Is it 500,000?
That's way too high.
That's too high.
Too high. Too high. Too high. 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 Bit more. Too low.
Too low? Too low?
Too low.
Okay, good.
Too high. Too low. Too high. Too low. Too low. Too low. Too high. Oh, too low.
Yep.
There we go.
All right.
There you go.
Awesome. So 20 guesses.
And how big can you make it?
Damn.
Like, does it?
I think up to like 2 billion. So this isn't bad. 20 guesses to guess one of a million numbers, right? If we were totally randomly guessing, it could have taken us a million tries. But it did 20 guesses and it got it. And in fact, it's always going to get it in no more than 20 guesses if we go up to a million. If we go up to a billion, we can guess your number within 30 tries.
It just splits it in half. Whatever.
So we're splitting it in half, yeah.
Can you
So, go ahead.
Sorry. Can you use the command line to enter in a smaller number than 100?
Yeah. So we can play high-low between 1 and 5. You got a number?
Yeah.
Okay. Is it 3?
Oh my god.
Whoa. Magic. And you notice I cheated. Instead of saying it took 1 guesses, I just said number of guesses, colon, so I don't have to worry about guess versus guesses.
Can we worry about it anyway?
Yeah. All right. So how does this work? This is an example of a class of algorithms called divide and conquer. And divide and conquer is a family of algorithms that will work with a lot in winter in 222. It's a really powerful technique. It's fairly simple in its basic nature, but it works well in a lot of situations. So the way divide and conquer works is basically you're trying to solve some problem, okay? If you can change that into a smaller problem whose solution is the same as the solution of the big problem, you've made your life a little easier. So the divide step is let's take an original problem, let's find a similar but smaller problem whose solution will be the same as the solution of the original, and then let's solve that. That's the conquer part. And how do you solve that smaller problem? Break it into an even smaller problem with the same answer, and then solve that. Well, how do you solve that? And you keep going until it becomes such a simple problem that you can solve it without any trickery at all. So that's the general style of divide and conquer. So let's say we're trying to guess a number between 1 and 100. So there's 100 possible things we could guess. That's pretty hard to do, right? If you only got one guess, you probably wouldn't be able to win this game, unless you just happen to know the person and pick the right number. So this is a really hard game to play. If we were playing a game where I said think of a number between 25 and 37, that's easier to play. There's quite a bit fewer guesses that I would have to make to figure out what your number is. Because there's only, 13 numbers that you could have picked. Here's the easiest game in the world to win. I'm thinking of a number between 27 and 27. Can anybody guess what that number is?
27.
Hey, magic. 27. It's an integer,
Oh, okay.
right? So
27.7.
that wouldn't be between those either. That's going to cost you a brownie. No. All right, so that's the easiest game in the world, right? Where you're thinking of a number between n and n. So the idea is, can we take your original problem, thinking of a number between 1 and 100, and change it into a simpler game with the same answer? So we make a guess. And we're going to guess 50. And suppose 50 is too high. Well, what do we know now? If 50 is too high, your original number was between 1 and 100, but 50 is too high.
It's got to be at least, or at most, 49.
It's got to be at most 49. Does everybody see that? Right? It can't be 50 because that wasn't correct. It can't be 55 because 50 was too high. Then 55 has to be too high also. So we've changed this into a new game where the lowest our number could be is 1 and the highest it could be is 49. And that's a simpler game. It's a smaller range to guess.
Huh.
Now suppose I make a guess of 10. Well, if it's correct, we're done, right? If 10 is too high, then what do we know? Well, it still could go down as low as 1, but it can't go any higher than 9. That's a really small problem now. But if 10 turned out to be too low, all we know is the number's bigger than 10. So it could be as low as 11, but it could still be as high as 49. So if we guess the number, if we know it's between 1 and 49, and we guess the number 10, we might get a really simple problem to solve, or we might get a problem that's almost as hard as the original. Okay, here's the worst we can do. Original game, low equals 1, high equals 100. Guess the number 1. Well, if that's incorrect, what does it change? Number's got to be at least 2. Okay, is it the number 2? Well, if it doesn't happen to be the number 2, we know it's got to be bigger than 2, so it could be 3 or anything up through 100. We're whittling the problem down, but by very small steps now. And if we're doing this algorithm and the person actually guessed the number 100, it's going to take us 100 guesses to get there. But if we start by guessing 100 and then 99 and 98, and if they pick the number 1, it's going to take us 100 guesses to find that. So the logic here is, depending on what number we guess, we basically divide the range of numbers into a smaller subrange. And if this is your original range of numbers, well, we can divide it anywhere we want. We can guess 10, we can guess 1, we can guess 100, right? But we don't know if it's going to fall to one side or the other of our guess. So logically, if humans are perfect, what's the best place to make our guess?
50.
Yeah, right in the middle. So divided right halfway point. And now, if we're right, we're done. But if we're not right, we're going to have a subproblem that's about half the size of the original. Whether 50 was too big or too small, our new problem is shrunk in half. And if 50 was too small, now we're looking at something in this range. Well, again, we're going to go right in the middle. And whether that's too high or too low, our new problem is going to be half the size of the original. So that's sort of our optimal approach to divide and conquer, is to try to cut things in half if we've only got two choices. That's what we're going to do in high-low.
And this is in bash?
This is in bash, yeah.
Are we gonna be rewriting it in C?
No, we're not going to redo this in C. PA4 will be different. All right, so you know how to play high-low now? Or you already did? All right, so let's look at the assignment. So it's a bash script that plays high-low against the user. So the user types the name of the script, hits enter. Program prints a welcome message, says welcome to high-low. And then ask the user to think of a number and hit a key when they're ready. Give them a moment to think of a number. Don't just start throwing guesses at them, right? So when you run HL, welcome to high-low, please think of a number between 1 and 100, and I'll try to guess it. Hit enter when you have a number in mind, or hit any key when you have a number in mind. So wait till they say, okay, I've got a number in mind, and then they hit a key. Okay, and then user thinks of a number, hits a key. The program will make a guess and tell the user what the guess is. And if the guess was correct, the user hits C and the game's over. Once the game ends, tell the user how many guesses it took and thank them for playing, and just exit. If the program's guess was too high, the user will hit the H key. If the guess was too low, the user will hit the L key. And in those cases, the program makes a new guess, and it just continues. Tell the user what the guess is, they put in H or L or C, and so on. Okay, and if you run this with a command line argument, then play between 1 and whatever that number is. Okay, no error checking necessary on this command line argument. Okay, I will run your program in exactly one of two ways. Either I will say HL enter, and I'll start playing the game between 1 and 100, or I'll say HL space, and I'll put in a legal integer. Okay, I'm not going to say HL haha, I'm not going to say HL 17.5, I'm not going to say HL ABC with spaces in between, right? I'll say HL space and a legal integer. So if you see an argument, you can assume it's an integer and play between 1 and that. So don't get bogged down in error checking of that argument. But if there's no argument given, then you just play between 1 and 100. Is that clear? So if your program crashes, if someone says HL haha, that's perfectly fine. You're not going to lose points for it. I'm not going to say HL anything other than an integer or nothing at all. Okay, so it's got to be written as a bash script. You got to put in comments, including the comment block at the beginning. I'm seeing really good work with commenting code, so keep that up. Don't require the user to hit the enter key after typing HL or C. Okay, single entry keystroke. I'll show you right now how to do that. Read answer. If you say read answer and you hit an H, it doesn't do anything until you hit enter, right? This is what we're used to. Hit enter, and now if I echo answer, it shows me what the answer is. Okay, if you don't want it to need the enter key, just say read-n1 answer, and now it'll read exactly one keystroke and it'll come back right away. So it says read-n1 answer, and you just hit a key and you're done. And if I look at answer, it's whatever that keystroke was. So don't do this in general if you want someone to type in a number or their name or something, because after one keystroke it returns. But if you want to just get one keystroke and return, read-n1. If you wanted to get two keystrokes, you could say read-n2, for example. Yeah. Okay, good. Yeah, so it's a general switch on read. But we'll use it just to make the gameplay a little swifter.
So is that command pretty much how, oh wait, never mind.
Yeah. Okay.
Because rogue's coded in C, right?
Rogue's coded in C, yeah. So getting that to work in C is a fair bit harder than it is in Bash.
Can we learn how to do that?
I've considered it. It's on my list of maybe.
Oh,
Yeah.
that'd be cool.
But I can definitely show you if you want.
Yeah.
Yeah. All right. So the two things you do need to detect are if you don't hit an H, an L, or a C, you have to tell the user hit an H, an L, or a C, and just keep going, right? Until they put in something correct. Okay. Let's say that I'm thinking of a number. I'm thinking of 75. So that's low, 75. Well, I don't want to lose the game that quickly, so I'm going to say 75 is too high, and this is too low. And 74 is too low. Okay, at this point it calls me out and says, hey, something's wrong. Maybe you forgot your number, parentheses, I think you're cheating.
You're right.
Right? Now how does it know this? Because earlier I said 75 was too high, and now I just said 74 is too low. Well, if you put those together, something's wrong. Right? Because it's got to be an integer. It's got to be less than 75, but bigger than 74. There is no such thing. So at that point, it just exits and says, sorry, something's wrong. So you want to detect that. Okay. So some gotchas to watch out for. Make sure that the user is the one picking the number and the program is the one trying to guess the number. Occasionally I get this backwards from students where the student's trying to guess the computer's number. Right? That's a totally different game.
Wait, that's the next one.
Yeah. All right. Also, H means the guess was too high. It doesn't mean make a higher guess next time. Okay? So the example here, if you're thinking of the number 10 and the program guesses 50, you want to say H. 50 is too high. Don't say L, meaning guess something lower. Okay? That's the opposite behavior. So you're telling the computer, is the guess that the computer made too high, too low, or correct? All right. And you're welcome to have other people try your code for you. Don't send your code because it's a bash script so they can see the source. But have them hop on your machine and run the code. If you're not sure that the code's doing the right thing, have each other play it. All right? Try to trip it up and see if it does what they think it's supposed to be doing. So you can QA on each other. All right, making sense so far? All right, so how do we do this? We're starting off with a game between 1 and 100, say, and we're going to make a guess, and based on whether that guess is high or low, we're going to end up with a smaller game to play, typically between 1 and 49 or 51 and 100. So we need to keep track of what this game is that we're playing. In other words, we need to keep track of what the lowest and highest numbers are that the person might have guessed. So we're going to need some variables. And I'm just going to call them low and high. I'm going to set low to 1 and high to 100. And what's our best way to guess? If we're trying to pick between any two numbers, just designated low and high, what's the optimal guess we should make?
Right in the middle.
Right in the middle. Okay, so how do we find the middle of two numbers?
Add them, divide by 2.
Add them and divide by 2. We're really just doing an average.
Is there an average function?
There may be, but we don't need one.
Oh, yeah, but
So low is 1, high is 100. If I say guess equals high plus low over 2, guess will turn out to be 50. Now it should have been 50.5, but things are integers in bash, so it'll automatically truncate it for us, which is what we want, right? So there's your whole AI calculation for what the next best guess is. It's just high plus low over 2.
And then we'd set, once they pick like an H or an L, we'd set that as that.
Yeah, you adjust your range. All right, so you want to flowchart this? So here's your whole PA3. So what does PA3 do? First, it welcomes the user. So print your welcome message to the user and tell them the basic deal and ask them to think of a number and wait for them to hit a key to say they've got a number in mind. Okay, and we know we need to have a pair of variables. Low is 1, high is 100. And there's this business of a command line argument. Right, so if there's a command line argument, then what do we do with that argument? What does that change in here?
Changing the value of high.
It changes the value of high. So we can do a single if here. So how do we read the first command line argument in the shell script? Do you remember? It's been a few weeks. $1. So let's see if $1 is empty. If it's an empty string, that means there's no command line argument. So if it's not equal to an empty string, I've said you can assume that it's a valid integer. So you can just say high equals $1. Okay, is that good? So that's your whole command line argument parsing part. It's one if statement. Okay, so what do we guess? High plus low over 2. Show the user the guess. And then ask the user for an H, an L, or a C. I'm just going to cheat here. Okay, ask the user for an H, an L, or a C. So what are the possibilities? Suppose the person types in C. What does that mean? It means we guessed the number. All right, so if they typed in a C, then the game's over. We're supposed to print out the number of guesses, right? So let's print number of guesses, and then we just return. So we need one more thing here. We need a variable to keep track of the number of guesses. So let's put that in up here. So initialize number of guesses equal to 0. And every time we make a guess, let's just bump that up. So num guesses equals num guesses plus 1. So the first time we make a guess, we're going to set num guesses equal to 1. If we make a second guess, we'll set it equal to 2. So that'll always be the number. Okay, but if the user did not type C, what could they have typed? They could have typed an L. Well, if they typed an L, what does that mean?
It was too low, so set that guess as low.
So we made a guess and it was too low. So let's say the guess was 50 and 50 is too low. Okay, so what do we want to adjust? There's a number of possible answers.
$, blah, blah, blah.
Dollar sign what?
Blah, blah, blah.
Blah, blah, blah. Forget about bash. Just think about variables. Let's change low, right? If 50 is we said is too low, right? So if 50 is too low, we don't need to guess 50 again, we don't need to guess 30, we don't need to guess 1, we don't need to guess anything smaller than 50. So let's change low. Do we really want to change it to 50 though?
Isn't it like, yeah, 51 and 49?
51. Right, 49 would still be too low because it's smaller than 50. We actually want to set it to guess plus 1. So let's do that. And then we've changed our game. We've said now we're trying to guess between whatever the old value of high was and this new value of low. So let's just go back up. And we'll come right back up here to where we made our guess, counted the number of guesses, showed the user the guess, asked if it was high, low, or correct.
Is that where you'd want to make a function out of that?
You could. This is sometimes an assignment where people start trying to use functions and actually makes things harder for them.
Okay, don't do it.
So if it makes sense to you, go for it, right? But if it's not jumping out to you like, oh, this would be so much easier with a function, right? Don't necessarily try to force one into there.
Okay.
Okay. So if it's correct, we're done. If it's low, yes, okay. So it's not correct and it's not low. What's the next possibility we want to look at?
It's correct. Oh, if it's high.
Could be high. Okay, so if it's high, what do we want to do? So we guessed 50, and 50 is high. What should we change?
I equals guess minus 1.
Is that your guess? Your answer?
I would say guess minus 1 equals high.
Okay, so 50 is too high, other way around, yeah.
Actually assigned in the right way.
Okay, so yeah, set high equal to guess minus 1, which is 49. Because we don't have to guess 50 or anything bigger than that, so we're changing the high end of our game. Guess minus 1. And we go back. And so this is most of PA3. Now there's one extra case left. Let's look at what happens when the user cheats. So suppose we said low equal to 49 and high equals to 50. That could happen, right? And the user might be thinking of 49, or they might be thinking of 50. If they're thinking of 49, your guess is probably going to be 49.5, which will truncate to 49. So if they were thinking of 49, the computer's going to guess it. If they were actually thinking of 50, you're going to say 49 is too low. It's going to change this to 50. Okay? If they're so this could get down to a case where low equals 50, high equals 50, guess equals 50. Okay, so cheating happens when there's only one possible answer at this point. We know it's got to be 50, and the user says, no, that's not correct. Okay, then you know something's wrong. So there's two possibilities. If they say that 50 is high, what are we going to do? We're going to change low equal to 49. Sorry, we're going to change high equal to 49. If the user says 50 is too low, we're going to change low equal to 51. And both of these cases are easy to detect because in both of these cases, low is bigger than high. That's how we're going to detect cheating. Now they can be equal and still a legitimate game. But as soon as low is bigger than high, we know that something's gone wrong. So you need to add one more piece of code in here every time that you change either low or high. Throw in one more if. If Low is bigger than high. If someone's cheating, exit the program. Otherwise, just continue. Go back up to the top.
Do you want us to print a message?
Yeah. Say something's wrong. I think you forgot your number. Goodbye. So that's PA3, right? It's a little bit of preamble up here. It's a big while loop. It's got a little while loop inside where you're, oh, sorry, there's one more case. If it's not an H, an L, or a C, go back up here and ask them again. So it's a little while loop inside a big while loop. It's a calculation with $, paren. It's a few if statements, and that's it. All right, questions? We got -3 seconds. Okay, cool. So start working on that. Break it down into pieces if you like. Have a good weekend. And I will see you. Okay.